everybody. Ian Kelly here from Energy Web. I'm going to be talking with you today about our latest digital spine update. And for those of you who have been following us for a while, I think you've heard me talk about digital spine before and our project with AEMO and Why Australia before. So I'm not going to rehash all of that, but give you an update on kind of the latest of what's going on, and it'll be a little bit of review for those folks who are newer to what we're doing here, but hopefully keep it interesting for those of you who have been around for a while. Great. So to get started, first of all, who is AEMO? AEMO is the transmission system operator in Australia. And the reason we're talking about them is that they have been the first major implementation of digital spine. And as I've mentioned in the past, this has been an excellent opportunity for Energy Web because Australia is really operating in the future. They are managing an electricity system that is years ahead of the rest of the world in terms of the level of penetration of solar. So distributed energy resources are a few years ahead there compared to where they are really in any other market in the world. And so we're able to implement this tech and prove it in a place that is dealing with the types of challenges that you see today in Australia, but we'll see in a few years in other places. So it's an excellent place to start. They're the ones, again, dealing with the challenges now. As others start to deal with the same challenges, we'll be able to say, look, we've already dealt with this. We've got the proof that it works, and so yeah, great opportunity for us. So AEMO manages, as I said, the transmission system. This is where we're talking about electric power, critical infrastructure here for the entire country. One organization for the entire nation, and they do this in basically two different markets or two different grids. They have the NEM, which is most of Australia. So everything that is not the WEM, the Western energy market, which is just in the western part of the country. So NEM for pretty much everywhere, WEM for the small part that's not in the NEM, relatively small part at least. And the latest, and we'll talk a little bit more about kind of the history, but just to give you kind of the highlight right now, the latest project, which is Project TED, that we have been working on with AEMO and other market participants. We have about 10 market participants in the project, and it was released to sort of an initial production level already, and they are aiming to really roll this out then in what it will be their summertime, that is wintertime here in the Northern Hemisphere where I sit, but their upcoming summertime, we're expecting to see that number grow to all of the usual participants in a few service markets, and we'll talk about what I actually mean by that in the next few minutes. So that's the kind of high level of what's going on working with AEMO, and the latest is this Project TED. TED relates to the WEM itself, but if all of these don't mean much yet, they will shortly. So let's move on. So we've got, again, a little bit of a review for folks who are following us newer to the space here, but a review of what are the problems we're actually dealing with, and why is Australia especially interesting. So in the next, under 10 years, they're saying 2032 here, but it was 10 years when that forecast was built. Half of Australian homes will have PV, that's solar, on their rooftop. And if you think about half, that is a mind-blowing ratio compared to where a lot of the rest of the world is. Certainly there are some markets who are doing well, but half for the entire country is, again, years ahead of where you will see anybody else at this point. The storage and electric vehicles, so basically these are what we would call distributed energy resources. So anything that is behind the meter, the electricity meter. All of these different resources will total about 30 gigawatts of capacity. And this is already double the current coal capacity for the NEM. So if you think about the energy transition we've talked about before, where we're moving from a small number of highly centralized traditional power plants like coal plants to a much more decentralized and distributed power system, this is exactly the things that we're referring to. We will have twice as much capacity in DERs as the traditional coal capacity in the main electricity market in Australia. So just again, this is for people who have been in the energy space for a while, this is really just a stunning fact about what's happening with the energy transition. But to understand that is so critical to understand why we're working there and what the potential is, what the opportunity is. Um, the challenge with all of these decentralized assets, as we've talked about in the past, is the central transmission system operator, AEMO in this case, doesn't have visibility on what all of these DERs are, where they are, who owns them, all of these kinds of things. And this is a common setup in these markets. The transmission system operator is traditionally only a B2B entity. It doesn't have direct relationships with consumers, and usually isn't allowed to have direct relationships with consumers. So there are regulatory reasons why there's a wall in between there. And this worked in the past. There was no reason for them to have relationships with the end consumers. They were just contracting directly with, again, as we talked about, the relatively small number of large coal plants or other generators. But in the future, this future where we have way more DERs than we have coal plants, not just by number, but even by capacity, um, this creates a challenge because you're trying to keep the grid operating, keep everything balanced, which is, as you may know, in grid operations, supply and demand always have to be in perfect balance, or your frequency gets out of whack, whether it's 50 hertz or 60 hertz, and all of a sudden you have very serious problems. And so maintaining balance, maintaining the frequency at any given time, incredibly important, and all the more challenging when you're dealing with thousands, tens of thousands, hundreds of thousands, potentially millions of distributed assets, as opposed to just 10 or 20 centralized assets. So that sort of gives you a sense for what the challenge is, what the problem is. We have an energy transition that's causing great new challenges. It's exciting, of course, but great new challenges for traditional grid operators. And they need to find new ways to actually adapt to this transition and support it. It's sort of unavoidable anyway, but we also have benefits in terms of system cost and, of course, carbon emissions. So it's good for the climate, it's good for cost for consumers, and it's just a matter of how do we actually make all of this work. So let's move on and talk a little bit more about some of these problems. I've given you the kind of the lay of the land in terms of the energy transition and what's going on in Australia. It applies to other grid operators. Again, maybe not quite as immediate, but on the horizon. But if we look a little bit more detail of what are some of the actual problems then that this presents, that's what we're talking about here. So we need the ability in these grid operations to share certain kinds of market data across participants. We have to do this in a way that preserves privacy. We have to do this in a way that, as we said, quite often there are regulatory reasons that certain participants, like maybe the grid operator, can't have relationships with the end consumers, and therefore can't actually see that data, that type of thing. So we have to be able to design a system that allows for sharing of data, but only in the right ways, and only in ways that preserve privacy, but still, allow the grid operator to do its job. So we have to maintain the system uh, uh, while still preserving privacy and meeting all of these regulatory requirements. So how do we actually do this? How do we allow the sharing of data when we are dealing with huge numbers of actual messages? And when a message here could be anything from the submission of a bid or an ask into a market. So if we have a specific ancillary service, and apologies for diving into some more power system nomenclature here, but the idea is a lot of these services are not just I'm providing electric power, I'm providing energy to the grid. These are also services relating to maintaining the frequency. So very small micro changes, but they need to happen very, very quickly if the frequency drops at second or even smaller intervals. Maintaining capacity on the market, so reserve capacity. So if there's a spike in demand, can we meet that? As I said, supply and demand always have to be in balance, these types of things. So it's not just providing the power itself, it's providing all of these little services sort of relating to the stability and operation of the grid that are related to power, but not actually selling energy to people like you and me who need to buy it at the end of the day to run our homes or our businesses. So as you are sending all of these messages relating to the market operations or activation of a device or an asset, we're talking about a system that could operate in the past in a very analog way. When you have only, say, 20 power plants, 20 generators that are participating in a market, and you need to call one of them and say, we need you to provide some excess some extra capacity here. You literally do that. When I say call, I mean literally pick up the phone. You can call them and say, okay, we're accepting your offer. Go ahead and do it. But you can imagine when we go from 20 coal plants to 100,000 DERs owned by people that we don't actually know or have any sort of relationship with, we're not picking up the phone anymore. So all of this needs to happen in a very automated way, and there are lots of messages then that need to be sent over whatever the solution is in order to make that operate seamlessly. So the scalability of the system, we need to be able to onboard these participants and send messages in an efficient way and do all of this in a way that, again, we're not just onboarding 5 or 10 organizations, we're onboarding potentially 6-7 figures worth of identities into a system. This scalability is incredibly important, and making sure that the system is secure with all of this. Again, this is critical infrastructure. This isn't something like when we build our green proofs registries, which I'm sure you're hearing about in another presentation here. These are, of course, very important. If something happens with the registry, though, for 5 seconds, we don't have an entire economy crash. Whereas with grid operations, you absolutely could. And so that's incredibly important that everything is tested and retested and incredibly secure, not subject to being penetrated by anybody, nefarious actors, whether they're working for a foreign government or somebody sitting in their basement wanting to cause problems or whatever it is. So the rollout for these types of things is much more process oriented. It's extremely intense in terms of the level of control and procedure that must be followed in order to roll these out. But you can understand kind of why the security of the system is paramount. So how do we though maintain that as we're scaling up from 10 very well known companies that are operating power plants to, again, 6-7 figures worth of assets in the future? So that's ultimately what we're dealing with here with Digital Spine is the solution to all of these types of problems. So the solution has to be able to allow these different market participants to exchange data. This can be, both among the main grid operator in Australia, that's AEMO again, but it could be the distribution utilities, or DNSPs as they're known in the Australian context. Aggregators, these are companies that actually have relationships with DER owners, so people like you and me, individual consumers who have solar on their roof or an EV or whatever it is, and they can kind of bundle up the capacity of these assets and bid them into markets in a way that uh, can allow for a little bit better coordination. And so, how do we actually enable the exchange of data among all of these different parties in a super secure, uh, resilient? I mean, again can't have downtime. If it's down for 5 seconds, we have major problems, that kind of thing. We have to be able to deliver messages in a variety of I don't want to say ways, but a variety of types of messages. So some of these messages can be very small in terms of the memory involved. They are simply activation signals, that kind of thing. Some of these messages could also be very big. They could contain attachments with lots of telemetry data or something like that. So we need a system that can handle a wide variety of message types and sizes. Um, and you can see a couple of the other requirements here. You need to, for all of these enterprise users, so the generators who have been involved in the past, as well as aggregators who are not part of older systems and that kind of thing. These are all different enterprise environments. They all have their own requirements. Many of these are operating or used to operate in a critical infrastructure setting. Some are maybe not used to that, but in any case, we need the ability for them to actually easily deploy their part of whatever the solution is. So digital spine for them needs to be something that they can easily deploy, manage themselves. If we make the perfect solution in terms of complexity, it could do everything, but you need to hire a team of 50 just to be able to set it up and run it. It's not the right solution, right? So it has to be able to do all of these things and also be very simple to actually provision. And and yeah, so I mean, it gives you a flavor for what we're trying to accomplish here. I'm not going to go into too much more detail on any of that, but you start to get a sense for what digital spine is really all about. So talk a little bit. You've seen versions of this diagram before, I suspect, if you followed us before. But when we think about the actual data exchange itself, there are a few different architectures you could use. In the past, these have been, uh, I guess, what I would call simpler, but more tightly coupled point-to-point solutions, where you either maybe you have standards, or maybe you don't. uh, Again, this could be as analog as just picking up a phone and calling somebody. But even within digital messaging, you had a much simpler history there in terms of how these things were set up. But that simplicity came at the cost of not really being able to be appropriate for the new kind of system that we need, given all of the DERs and the energy transition. So what we have come up with is this decentralized data exchange. This is the digital spine. So there is a central's kind of a confusing word, but a shared message bus. So this is the actual message broker itself. And all of the participants, the grid operators, the distribution system operators, the aggregators, everybody else, they are able to connect with their own identities that are self-managed. So they connect with their own client gateways, is what we call them. And we use system-wide agreed standards for what the messages are. And this all sounds a little bit vague. We'll get a little bit more detailed about what this all means in the next few minutes. But essentially, this is, we call it digital spine. We call this digital infrastructure for the energy system. This is exactly what we mean. It's let's set up a system where these messages can be shared uh, in a very targeted way across participants who are managing their own identities, who are provisioning the service themselves. And this shared system across all of these different participants will allow them to operate the grid in the way that they need to operate it, or participate in markets relating to the grid operations in the way that they want to. So talking a little bit more about this managing your own identity. You know, again, if you followed us for a while, you've heard about decentralized identifiers, or DIDs, and Switchboard, which is our system for you know, setting up DIDs and namespaces around DIDs and that kind of thing. We've been working on this for years, so this might be familiar to at least some of you. But there are some really important differences between a traditional siloed identity system and a self-sovereign identity system, which is what DIDs are based on. So in a traditional siloed system, you think about this as username and password. So any sort of Web2 system where you are accustomed to signing in, you give a username, you give a password, and the centralized system checks and makes sure in this big database they have of every user with their username and password that these two things actually match. And that's how you authenticate into a system. Self-sovereign identity is described here. Um, it's a very different approach. So you're using a public-private key pair, you're managing identity based on that, and you are able to prove and authenticate into the system, prove your identity based on having that private key. You've also started to see, just as a quick aside, you've started to see this being rolled out, this more Web3 kind of identity approach rolled out by some of the big sort of traditional tech firms, at least in the U.S. So you know, Amazon and Google and Apple. These are companies that are all when you sign in, you can actually sign in. You can create a sign in with keys instead of your traditional username and password. Maybe you've been prompted to do this and not fully understood what it was suggesting for you, or maybe you have. But that's it's a similar approach. Because there are these obvious benefits to it. And again, we're using it in Digital Spine because, well, we'll talk about a few minutes. I don't want to get ahead of myself here. So yeah, within the space here, we've got this public-private key pair that you're using. You as the user are holding the identity yourself. It's not being maintained in a centralized database somewhere. And the exciting thing of what this unlocks then is the ability to issue verifiable credentials. So what that means is you create an identity based around your key pair, and you can say, uh, you know, imagine I want to be able to prove that Ian, I'm authorized to drive a car. So you could get basically a signed statement from whoever the government authority is in this example that says, yes, he's authorized to drive a car. We have him in our system. And then, you know, I as Ian can present this signed statement from the government authority to a third party. Um, and they can see, because it's been signed using that government agency's key pair, that this is actually true and reliable. And so I can manage my own identity, and I can get these credentials signed by whoever else I need to sign them, whoever's reliable to the company that I'm presenting to. And this is a way for me to manage my own data, manage my own identity. And in the context of Digital Spine and Switchboard, we're using this because imagine you as a participant in these markets. You want to be able to send a message. You know, one-on-one, this is easy. You can say, send a message to Ian. But imagine you say, I want to send a message to every user that has the role of aggregator. I don't know who they all are, but I want the message to go to all of them. So you can use the namespace system from Switchboard. And within Digital Spine itself, simply have that message addressed to all users that have that role type. And if they can prove that they're an aggregator, if they have that role, then they can receive that message. So this is a way that you've built scalability right into the system from the ground up. So we can send messages, whether it's AEMO as the grid operator needing to send messages to all participants who have a certain role type, or other participants needing to message each other for whatever reason. There are many different potential types of roles you could have within these systems. These roles could vary from one market to another, one service to another, all of these kinds of things. So you can be very precise with targeting messages, and the digital spine just handles all of this automatically. So it routes all the messages to where they need to go. It's incredibly secure. It's reliable. You know that the message came from who you think it came from because it's signed. So there's really no, that addresses security concerns. You're not worried about, is this a hacker who's actually telling me that I should activate my device at this point? But it's not really, or something like that. Everything is secure, but in a very decentralized way. Great. So let's move on and talk a little bit more about. I've actually gone over more of the benefits. So let's just move on here and talk about kind of decentralized technology. So how do we actually how does this digital spine work? In the edge and symphony contexts, if you think back to our early projects with AEMO, these were the first two major projects. We were using our blockchain for the identity management. You can see we've continued with the same approach, or very similar approach, with Project TED, which is again the most recent implementation. So let's talk actually a little bit, just in the interest of time, about what we've actually been doing with TED. So again, the main components are the DD hub, so the message broker itself, together with client gateways that any of these participants can easily deploy to connect to the system, and then switchboards, so the DID approach, the identity approach underneath it. The data hub itself, so this is again the message broker with the client gateways. The idea here is we have a shared piece of infrastructure that all of the messages are sent to and then routed to where they need to go. And they're not retained in that message broker, they're simply routed. So we don't have a central repository where all of the messages sit and could be hacked or something like that, but they're routed where they need to go based on the DIDs or the roles. However the message sender has configured that message to be sent, it will be routed very precisely to where it needs to go there. So when we do that, again, it allows for great scalability. It allows for great system security, and you can be precise in terms of setting up messages for these specific services. You could be sending messages in a more of a broadcast way to all participants, or all participants who have a particular role. It's hugely customizable. And we did this, of course, on purpose, because if we design the digital spine only for the Australian context and then have to basically start from zero for another market, this isn't a very efficient way to do it. So we've designed that sort of customizability and scalability in from day one, so we can then easily customize it for new use cases within the Australian context, or of course deploy a digital spine solution in another market relatively quickly, because everything is so customizable. Let's see here. So I think a few things to say here about about the key features of the digital spine itself, the data hub portion of it. So again, it's DID based, and we use that for authentication to the system and also authorization in terms of what the users are able to do within that system. Um, it's based on the verifiable credentials again, so we can issue VCs, as we call them. This is how roles are assigned. So if you are an aggregator, you can take on the role, a role of aggregator within the system. And then those messages that are broadcast to all aggregators, you can set up a channel where you receive those messages as an aggregator. And so, once you've set this up, it's really seamless and everything just, works pretty smoothly there. Um, so this is a way that the hub, again, very customizable. It's generic enough that you could use this in a variety of different contexts, whether that's a specific service that you need in a market or whatever it might be. And again, the client gateways. So the way what each market participant needs to provision, we've set this up in a way that makes it as simple as possible for them to actually get set up in their own environments and connect to that message broker, and thereby participate in the decentralized data hub. They are just generating a new public-private key pair, setting up their DID based on that. And so they have an identity, and then a lot of that becomes really seamless with the way that it's set up. And so once all of this is done, they're connected to the system, and then we configure what are called topics, which are just types of messages and channels, types of messages that are sent to each other among the different participants. So, again, try to make it as seamless as possible for these different market participants to just get in and do what they need to do for grid operations. At the end of the day, this is meant to be, again, even the concept of digital spine or shared infrastructure, it's just meant to be something you don't see or think about. It's meant to be something that just works. And you as an aggregator or a generator who needs to participate in this market, your day-to-day business is just submitting into a market and getting called on to activate when you're called on to activate. This is what you do. You don't need to be an expert in Web3 or anything like that in order to participate. You're doing your core business, and it's just sitting on top of this that gives us all the benefits that we've talked about in the past as far as scalability and security and all that kind of stuff. We've talked a little bit, or I've mentioned just a moment ago, channels and topics. I mean, really what this is about is, for anyone who's used Teams or Slack or something like that, you have specific channels that can be set up. And you can name them whatever you want. And this is the place where we'll talk about this, whatever the subject matter of that channel is. What we're talking about here is a kind of a step further than that, because these are channels where we are specifying a particular expectation, as a particular schema, which is an expectation of exactly what the messages will contain. So you could imagine setting up a channel that says this channel is only to be used for sending messages that relate to this very specific ancillary service in this specific market. And so all of the messages that are in this channel will contain exactly these fields in this order. And so every participant, when they want to integrate that with their own system, they know exactly what to expect. The message won't be, when we say messages, we're not talking about you or I sitting at our computer and typing out a bunch of, free form text on our keyboard. We're actually talking about very specific, there's a field that relates to what time we are available to submit or to be activated, how much energy we could be activated for, how much power we could be activated for at that time. what is the price that we're submitting, lots of very detailed things that are necessary for those market operations. These get baked into the channel itself. So anybody who's integrating with it, they automatically know what are these messages going to look like, and they can then again, run their operations based on that. We don't need a human to parse what's happening across these different messages. We can if we want to, but we can automate all of that, and that speaks to the scalability. Maybe just a kind of final note or two. With the TED project, as I mentioned, so we started with Edge and Symphony in Australia. TED is the most recent project. We're dealing with 3 different ancillary services. For folks who are not from an electric power sector background, this is maybe not as interesting, but just to give you a flavor of the types of things we're actually dealing with, so that it feels real. We're dealing with 3 specific types of services, and they're described here. These are services that relate to how do we keep the grid operating, especially in summertime, when we see lots and lots of solar power that is variable coming onto the system. And again, we need to keep it in balance. So supply and demand have to be equal at all times. But how do we keep them in balance when we have a supply from what has historically been an unknown number of generators, and they're doing this even though we don't know who these generators are, how many there are, where they are, all of these types of things. So these are the 3 specific services that TED relates to. And yeah, I mean, we're really excited to see them actually using the digital spine in the actual market operations. So again, we've moved from let's do a POC, or let's do a kind of a theoretical test, to let's actually operate the grid using this stuff. And let's do it with these 3 different services that will help us operate the grid and integrate all of these DERs into the service provision. So that's where it gets really exciting for us. We can talk a lot about DIDs and verifiable credentials and messaging and all of this kind of stuff, but at the end of the day, what are we doing with it? In this case, we're actually allowing grid operations to proceed in the energy transition, integrating all of these DERs into the system. So yeah, I mean, it's actual impact, and excited to hopefully, next time we give these presentations later this year, we'll have more of an update for you on how that's been going with these 3 different ancillary services. So great, that's what I have prepared for you all today. I hope this was interesting. I know it was a bit of a deeper dive, and got a bit technical at times, whether it's in power sector stuff or kind of Web3 stuff, depending on where you sit. Might have been some new concepts, but again, really hope it was interesting, and look forward to talking with you all next time and giving you a further update. Thanks so much.